All right. So we started in chapter 5 to add and subtract and multiply expressions, right? Polynomial expressions. Now we're going to do the same thing on functions. So basically, you can take two functions. So suppose you have f of x and g of x, right? You have two different functions. Like f of x is something that looks like this. G of x is something that looks like this. You can take those two functions, you can add them, you can subtract them, you can do all sorts of things to them. Now, suppose you wanted to add f of x plus g of x. You would write that like this, or in more concise notation, so we're not wasting too much lead, in more concise notation, I can write this exact same thing literally in more abbreviated form, and it looks like this. F plus g of x, okay? So rather than doing f of x plus g of x, it's more expanded form. I could write it in a more concise abbreviated form, f plus g of x. So whether you have this notation or this notation, those two mean the exact same thing. It's just a different way of writing it, all right? So whether you say you're 17 years old or 13 plus 4 years old, same exact information, okay? All right, so that's when we're adding. And then when we're subtracting two functions, I can write it in concise form, f minus g of x, or I can multiply f times g of x, or I can divide f divided by g of x, okay? So let's take a look at these and let's do some examples. All right, so here I have f of x is this and g of x is this. I'm told to find f plus g of x. Basically, all I need to do is add the two functions. So the first function, f, is 3x squared plus 7x. The second one is g. Now I'm adding them, so I don't need to introduce any parentheses. And I put in g of x, 2x squared minus x minus 1. And then all of a sudden, this becomes an algebra 1 problem where you just have to combine like terms, right? So this is 5x squared plus 6x minus 1. Okay? So that's f plus g of x. Now, f minus g of x, we're going to take f again. This time we're subtracting, so I do put a parenthesis around the second function. Yes?
Why isn't it 3x cubed?
Well, because when you're adding like terms, the variable stays the same. You just add the coefficients. So it's 3 apples plus 2 apples, it's 5 apples. How many x squares? I have 3x squares and 2x squares. That's a total of 5x squares.
But if you're if you're foiling out the x.
We're not foiling, we're adding. So it's just adding. It's f plus g of x. That's the thing. It's one function plus another function.
It's not times.
Not times. It's plus, right? This one here is a plus. Okay? And here, this one is a minus, so I have a minus in between. And now I'm going to need to distribute that minus sign. So it'll be 3x squared plus 7x minus 2x squared plus x plus 1. Again, combining like terms, I have x squared plus 8x this time plus 1. Okay? Cool. Now here, I'm multiplying. I have a fresh function f and g, and I need to multiply them. Okay? So multiply. So I've got 3x squared minus 2x plus 1 times x minus 4. Okay, so here I can either multiply the longer polynomial into this, or I could go the opposite way. It's actually quicker if you distribute the shorter function into the other one. right? I mean, I don't know. For me, it's quicker. I guess it's the same number of multiplying, but I kind of like this more.
Can you do synthetic division?
No, because we're not dividing here. We're multiplying. Okay. Oh, sorry. Okay, so here, when I distribute the x, I'm gonna get 3x cubed minus 2x squared plus x, and then I'm gonna distribute the negative 4. So negative 12x squared plus 8x minus 4. All right, here I combine like terms again. Minus 2 minus 12 minus 14x squared plus 9x minus 4. Okay, questions? No? Okay, so let's do f over g of x. Here, I'm going to take f of x. Below it, x minus 4. Okay, now here. If there is a way that you can factor the numerator and you get, let's say, x minus 4 times something else so that you can cancel something from the top and the bottom, then you go ahead and do that. However, if factoring the numerator is not going to get you any further, it's not going to allow you to cancel anything, then you don't even have to go there. Does that make sense? Okay? All right. So, yeah, that's it. You just leave it that way. No. No. Okay? I mean, you could do it for fun. Right? Right. Yeah. All right. So, let's talk now about composition of functions. So, remind me, have you guys done something that looks like this in algebra? No. Like this? F of g of x? No. Okay. So, that's essentially what we're going to find here. We're going to find composition of functions. What if one function was made of another function? In other words, what if you can take two functions and put one inside the other? Okay? So, let's do a little bit of work here. Okay, if I have f of x is equal to 3x squared plus 5x, okay? Now, if I needed to find f of 5, what would I do? Plug 5 into where? All of the x's, right? Because look at what happened here. The x got replaced by 5. So here, every time I have an x, it gets replaced by 5. Okay? What if I needed to find f of 2a? You guys are experts at this by now. What do I plug 2a into all of the x's, right? 3 times 2a squared plus 5 times 2a. Now, what if I had to find f of g of x? Then what do I put into each of the functions? G of x. So to us, it doesn't really matter what it is that we're putting in, right? I mean, what do we care? We're just the ones who are substituting, right? So it doesn't matter what they give us to substitute. We just go ahead and substitute the same way. So here, 3 times x squared. Here we put in g of x plus 5 times x. Here we put in g of x. Okay? That's what we're going to do. Now, again, I can write f of g of x, but just like we talked about before, there is a more concise notation. There is a second notation. It looks like this: f circle g of x. Those mean the same thing. F of g of x. Okay? They mean the same thing. So here, that's what we have to do. All right, so take a look at what we've got here. what we're going to do is we're going to begin with the first function and then replace each x with the second function. So here's what we do. I have f of x and g of x. Here I need to find f of g of x. If you like, let's write it this way. I find students do better when it's written this way. It's easier to visualize and see. So f of g of x. So what's going to happen here? Inside my f of x, what am I going to put in? What am I going to put in for all the x's?
2x minus 1.
2x minus 1, right? So this is f of x. Wherever I see an x, I'm going to put in g of x. So 3 times 2x minus 1 squared minus 2x minus 1 plus 4.
Oh, so you're replacing.
You're replacing. If you want, what I tell my students to do sometimes is whatever the first function is here, in this case it's f, right here, write down f of x so you see it better. Right? So now for every x, we're going to put in the 2x minus 1. Should we do that again? Oh, you guys are good. We're going to do another one right now. So, oh, we do. We do. So now here, this is 3 times. Okay, what does this red stuff give me here?
4x squared plus 1. Minus 4.
That's the one. You're going to get 3 terms. Square the first one, you get 4x squared. Square the last one, you get plus 1. But inside, 2 times negative 1 times this. So negative 4x plus 1. Okay? All right. Here, minus 2x plus 1 plus 4. Minus minus here makes plus. Okay, then 12x squared minus 12x plus 3 minus 2x plus 5. So f of g of x is finally 12x squared minus 14x plus 8. It's okay, happens to the best of us. Okay? How does that sound? Intense. Let's do it again. Let's do another one, but this time it's g of f of x. Okay? What's the first function here? It's g of x, right? Look at this one here. The first function is g of x. So here's what we're going to do. Just write down g of x here. What this is asking me to do is find g of f of x. So look, for all the x's in g, I'm going to put in f of x. So that's going to be 2 times 3x squared minus x plus 4 minus 1. Okay? So, distribute 6x squared minus 2x plus 8 minus 1. So g of f of x is equal to 6x squared minus 2x plus 7. All right? Okay, so for this next one, I'm going to start you off, and then I'm going to have you continue on your own. So here we have f of x, g of x, and we need f of g of x. What's the first function here? The first function is f, right? So I'll ask you this way. What is going into what? Tell me. G is going into f, right? G is going into f. Okay, so we need f of g of x. Okay? The outside function is f. Why don't we write f of x here? wherever I see an x, I'm going to put in g of x. So I'm going to give you about a minute, and I want you to do f of g of x. If you get I'm going to be walking around. If you get the okay by me that you did it correctly, then you're going to move on to g of f of x. Okay? All right, ready, set, go. I'll pause this for a few minutes. Side of g. And this one has a little bit more work. Okay, any volunteers for an answer here? Yeah.
For A,
B.
for B, x squared plus 11x plus 18.
Any other answers?
No, that's wrong. No, it's right. Yeah.
X squared plus 11x plus 18 is right. So here you get x squared plus 8x plus 16, and then all of these constants will turn into 18. Okay, now this bit. So we have f of x, g of x. Now we need to find f of g of -1 and g of f of 3. So the best way to do these is start with the inside. Okay, so first I need f of g of -1, right? What I do is I start from the inside, g of -1. And we know exactly how to do that. This is g of x. I put -1 inside of g. So it's 2 times -1 squared minus 6 times -1. This is why we have you do all that in the beginning of the year. Okay? So how much is g of -1? 2 plus 6. I'm getting 8. What do you guys think? 8. Now I go back to the outside. What was I looking for? F of that number 8. That will be 3 times 8 plus 2, 26. Okay? So it's always easier to start from the inside and go out. Now, you can first find f of g of x and then plug in -1. This is just so much simpler, I feel like. All right, so go ahead and do this next one, g of f of 3.
Can you write the answer out?
I'll pause this for a minute. Okay, what do we think? Anybody have an answer? Ariella? 176. Any other answers? 176 sounds good to me. Okay, so 176. Okay, questions. All right.